Namaste everyone, hope you are doing well. Today we will have some discussion on refraction. We saw the reflection in curved surface, plane surface and all. Now refraction in different surfaces. First, plane surface. What do you mean by refraction first of all? We know that light in an isotropic medium travels in straight line, what do you call rectilinear propagation of light. Suppose a medium changes its density, optical density. Suppose the velocity of light changes as it moves through a medium or when it enters a different medium. Then what happens to its path? Then the light changes its path. So change in the path of light or change in the direction of light when it travels from one medium to another is called refraction. So that is one definition. So change in the direction of a ray of light when it travels from one medium to another is called refraction. Now how does it change its direction? Because the change can be brought in many ways. What is the actual change? Suppose you have a glass slab like this. So this is a glass slab, I will name it ABCD at the corners, and suppose these two sides are exactly parallel. Then take a ray of light like this. And air is an isotropic medium. What do you mean by an isotropic medium? The medium where density is always same throughout. Density in the sense optical density. So if you take a laser beam in this classroom, if you put the laser beam from one corner of the room to the other, with what velocity that laser beam will travel? Will it travel with the same velocity if it is put on from the other corner to the opposite corner? Will it be the same? If laser beam is made to pass in all directions inside water contained in a bucket, will it travel in the same velocity in all the directions? Yes, because water is an isotropic medium, its optical density is same throughout. Air is an isotropic medium. But as you go above and above the earth to a very large distance, then very large heights, then the density of air will vary. But within our activities, say a few meters of height, density of air is not changing to a very large extent. So you can say that air is an almost isotropic medium within a certain height, then light travels with the same speed. So here when the ray of light is incident at an angle, and you know how to measure all these angles, it is by drawing a normal. So draw a normal at the point of incidence, and you know that a part of the light gets reflected. Always there is reflection. Even the surface of water reflects light. Most of the light may enter in, but a part of light gets reflected. That is why we were able to identify the surface of water. If surface of water was not reflecting any amount of light, how could you have identified the surface of water? How could you see the surface of water? It is not possible. We will be able to see anything when light comes from it to our eyes. If no light comes from the surface of water, we were not able to identify the surface of water. But surface of water also reflects a small amount of light, but major amount of light enters in. How does it enter in? In the same direction, or in this direction, or in this direction, or in any direction as it likes? No. There is a particular rule followed here. It follows the particular law. And when it enters a glass, now if you see the activity of light, light travels with the highest speed in vacuum, and the difference in the speed of light in vacuum and air is very little. So for the time being, for all the discussions, I will assume the velocity of light in air and vacuum are almost the same. So in air, light travels with very high speed. All colors travel with the same speed, and white light contains all colors. You call white light and ask, who are your friends? How many of you are going together? It will say, sir, we are many in number, violet, indigo, blue, green, yellow, orange light, red, and all of us are traveling with the same velocity in the same direction. So we are all together, we are white in color. As soon as it enters glass, every color travels with different speed. Red travels with some other speed, velocity of red decreases, and velocity of violet also decreases, but decrease in velocity for violet is much more. Its velocity decreases by a large amount. Decrease in the red is not as so much as violet, but every color will show some other velocity, but lesser velocity when it enters glass. Say this is glass. So when light enters glass from air, velocity of all the colors will decrease. So what do they do? Now let us trace only one ray of light. Say this is yellow light, monochromatic light. Light containing only one wavelength is called monochromatic. Let us take only one yellow color light. Now what happens to the yellow color light when it enters the glass? I will represent the normal with the pink line now. Since the velocity decreases, light selects the nearest path. Imagine this glass slab was absent. Say this is the finishing line of 100-meter race. Yellow color was traveling like this. Suppose there was no glass slab, the yellow color would have traveled straight and might have reached the finishing point here, because this is the ribbon that is held, the last finishing point. One who touches this ribbon first is treated as the first placeholder. If there was no glass slab, ray would have traveled straight. But as soon as glass slab is placed, velocity of velocity of yellow color decreases. It will not be as if it was in air. Its velocity will decrease that as when it was in air. Now here it is less. But yellow color wants to reach this finishing point in the same time as it was reaching. If there was no glass. If there was air only, it would have moved straight and it would have reached the final point here. But now, since glass is placed, yellow color cannot travel, or any monochromatic light cannot travel with the same speed as in air. Velocity of light decreases. So now to reach the finishing point in the same time, that color of light makes an agreement. It doesn't travel in this path. It selects a smaller path, a shorter path, because its velocity has decreased. So it selects a shorter path like this, because this distance is shorter than this distance. Suppose there was no glass slab, well, that light would have traveled with the same speed and it would have reached here. Since there is glass slab now, in order to reach the same point in the same time, but its velocity has decreased, so the light selects a shorter distance. It is there is a very beautiful narration for this. Suppose there is sand here, seashore. This is sand, and from here onwards there is water, right? And you are standing here. You are a very good swimmer, and somebody swimming here, but you are on the land now. Even though you are a very good swimmer, you are on the land. Somebody here is swimming, and there was some confusion, and they cry for saving themselves. Suppose he can't swim and some very heavy waves have come, or suppose he has come across some problem. Now he can't swim and he is sinking in water, and he is crying for help. He is crying, help, 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 help. This person. What about you? Which path will you travel? Will you select to save him? Because you want to reach this person as early as possible. What would you select? Definitely your velocity in sand will be more than your swimming speed. Swimming speed will not be as fast as running in sand. Of course, walking in sand is difficult, we know it. But still, you can walk faster in sand than swimming in water. So, will you select this direct path? Or will you select a longer distance in the sand where you can travel faster and reach this person in a shorter distance in water? Here you can select a longer distance, because in sand you can travel faster. Select a shorter distance in water, because where you can swim slower. Will this path make you to reach this person sinking quicker than this path? Think about it. Then you will find that this will be the easiest path. Of course, there are many easiest paths. Sir, whether this path is quicker and can you reach him very quickly? Whether this path is more quicker, then you have to go for trigonometric functions. Which path will allow you to reach this person who is sinking quickly? And that is a very particular distance or the path. The same thing is done by the light here. Light selects a path which is having a shorter distance. Since its velocity is more here, since its velocity is less here, it selects a shorter distance in the place where its velocity is less. Of course, Snell, very great scientist who did many experiments in optics, and many scientists studied this, and finally Snell came to know that there is a particular rule with which the light has to travel so that it will reach here very quickly. And what is that? So here, since the velocity decreases, velocity of light in air is greater than velocity of light in glass. Suffix represents velocity in which medium. Don't take the like velocity of air and velocity of glass. It is not the glass traveling, it is not the air traveling. It is the light traveling in air, light traveling in glass. So V represents the velocity of light in glass, velocity of light in air. So since velocity of light in air is more than velocity of light in glass, here light selects a shorter distance, and if it has traveled like this, it would have selected a longer distance, so it bends towards the normal. So if the speed decreases when a light travels from one medium to another, if the speed decreases, then the ray bends towards the normal. When a ray of light travels from rarer to denser medium, this is optically rarer. I am not saying mass density. Optically rarer medium to optically denser medium. Then the velocity of light decreases and it bends towards the normal. You see the original direction? Compared to that, it has not gone away from the normal. It has gone nearer to the normal. So this statement should be very clear with you. When a ray of light travels from rarer to denser medium, so this is rarer, optically rarer to optically denser medium. I am not talking about mass density, I am talking about optical density. When a ray of light travels from optically rarer medium to optically denser medium, it bends towards the normal, its speed decreases. So all these three are together. So now, as usual, we will define angles. Angle between the normal and incident ray, this is the angle of incidence. Angle between the normal and refracted ray, this is the angle of refraction. Of course, it is always with respect to normal, we have seen it in reflection. So if you are asked what is angle of incidence, it will be a very silly question, it may not be asked, but you must know it. Angle between the incident ray and normal is called angle of incidence. Angle between the refracted ray and normal is called angle of refraction. So when a ray of light travels from rarer medium to optically denser medium, it bends now towards the normal because its speed decreases and it tries to follow a easier path, or that means shortest path. Okay, reverse it now. If a ray of light is traveling from denser to rarer medium, of course I can have the same diagram. I will go inside a glass slab, simply imagination, and I will put a laser beam from the inside part of the glass slab outside. How will be the situation? So glass here, and this is glass, and here is the normal, and here is the ray of light I have put like this. So inside the glass I am sitting and I am putting a ray of light from inside part. This is the original direction. If the glass was continuous, if there was no air, this ray would have traveled straight. But there is a change in the medium, ray should change the direction. You know that velocity of light in glass and velocity of light in air, if you compare, velocity of light in glass is less than velocity of light in air. That means as soon as it enters air, its velocity increases. So it should select a longer path to reach the final point. So it should select a longer point. That means it bends away from the normal, not like this, hit like this. So when the velocity of light, or when the speed of light increases, when a ray of light travels from denser to rarer medium, optically denser, when the light travels from optically denser medium to optically rarer medium, its velocity increases. Now it bends away from the normal. So when a ray of light traveling from denser to rarer medium, its velocity increases as it reaches a rarer medium. Immediately it will be thrown away. It bends away from the normal medium, away from the normal. Sir, what is the angles? What are the angles here? Angle between incident ray and normal, angle between refracted ray and normal, angle of refraction. Here R is greater than I because it has bent away from the normal. Here R is lesser than I because angle should decrease. It should bend towards the normal. So all these things should be very pakka in your mind. There should not be any difference or confusion in this. It should be very, very particular here. Okay, so you should choose a path in the sand little more and a lesser distance on the inside water because you have to swim. Because swimming velocity will be less and running velocity will be more on the sand. Now which path is possible? Because this is also possible, this is also possible. Shall we select as longer distance as possible in sand, as shorter distance as possible in water? That is also not fair. You have to select the distances in such a way that. So Snell gave an idea using the trigonometric function. We will define the laws of refraction here. When we design the law, we will come to know which path is better. Laws of refraction. What are the laws of refraction? First law, same as the second law in reflection. What does the second law say? The incident ray, the reflected ray and the normal all lie in the same plane. Because you can't expect the incident ray coming like this, reflected ray going like this. Not possible. It should be on the board because normal is on the board, incident ray is on the board, all of them should be on the board. So here also incident ray, refracted ray and the normal. Which normal? Normal drawn to the surface. Where? At the point of incidence. You can't draw a normal here and say that this normal also lie in the same plane or a normal here. No. The incident ray, the refracted ray and the normal drawn at the point of incidence to the surface. You have to give the full address of the normal. Normal drawn to the surface at the point of incidence all lie in the same plane. First law. So first law of refraction is when a ray of light undergoes refraction when it travels from one medium to another, the incident ray, the refracted ray and the normal drawn all lie in the same plane. But don't write incident ray, refracted ray and normal ray. Normal is not a ray because you are very good in writing rhyming words like Jack and Jill went up the hill. But it is not so here. It is normal is simply a line. It is not at all a ray. Just for our convenience we have drawn a normal. So incident ray, refracted ray and the normal drawn at the point of incidence to the surface all lie in the same plane. What is the second law? So I don't write the first law. Simply I mention it. What is the second law? Second law is very interesting now. Coming back to this one. Person is is crying for help and you are on the sand, you are a very good swimmer, but you can run faster in the sand. So you don't select this path because this gives you more distance in water where you will swim with the lesser speed than running in sand. So whether this is suitable, more distance in sand and less distance in water, whether this is suitable, Snell gave a solution for this. Snell's law. Snell is the name of the scientist. You take the angle of incidence here, you take this angle of refraction here, then the light ray will bend in such a way that you take the angle of incidence and angle of refraction, then calculate its sine theta values. Sin I by sin R is a constant. He said, when a ray of light travels from one medium to another medium, it changes the direction. So angle of incidence is not equal to angle of refraction. But the ratio of sine of the angle of incidence to the sine of angle of refraction is always a constant. Very easy statement and very dangerous statement. If you miss with one word, you will lose all the marks. I'll tell you which words you are going to miss in the exam. The ratio of sine of the angle of incidence to the sine of angle of refraction is a constant. Sir, is it true for any angle? Yes. For example, suppose this is the incident ray and this is the refracted ray and this is the normal, say. Sir, I go for some angle of incidence and some angle of refraction. Okay, calculate it using a compass. I'll give you a glass slab. Take a beam of laser, let it undergo refraction. Using a compass, you measure what is I and R. Using your log table and all, you calculate sin I by sin R. Sir, I got the value 1.33 answer. Okay, I'll give that glass slab to another student and I will ask him or her to calculate again sin I by sin R. Using different beam, same color light, but at some other angle. That the student will enter the lab. He or she takes different angle of incidence and he will get different angle of refraction, R dash. Then he or she calculates sin I dash by sin R dash. He will also get the same answer, 1.33. I will ask one more person, third student. Please take this glass slab, go to the lab, take a yellow ray, put it onto the glass slab, find out some angle of incidence and some angle of refraction, calculate this. She gets the different angle, I double dash, or I will write some angle x here. So for her experiment is with the different angle of incidence and with the different angle of refraction. I'll call it as x and y. Calculate sin x by sin y. She will also get the same answer, 1.33. Or if I call another student and give the same glass slab but different colored light. Suppose that student does the experiment with some angle I and R. Will she get the same angle of refraction for the same angle of incidence? No, that constant changes. That means this sin I by sin R experiment for a medium depends on the same pair, same color of light. So if you try to calculate sin I by sin R by calculating the angle of incidence and angle of refraction, whatever be the angle of incidence, you will get a corresponding angle of refraction. That will be a constant. That is possible when you take the same media pair and the same color of light. If you change the color of light, that constant will change. So Snell's law goes like this. I will complete the Snell's law now. When a ray of light undergoes refraction, when it travels from one medium to another, the ratio of sine of the angle of incidence to the sine of angle of refraction is a constant, provided it's a constant for the same pair of media and for light of given color. Suppose you change the media, instead of glass, if you start holding a plastic, then sin I by sin R will be a different constant, and even R will change for the same I. Then you will get a different constant. So you have to mention that if you take the same media and the same color of light, but you are given freedom to use any angle of incidence and refraction, but this will be a constant for that pair of media and light of that color. So the ratio of sine of the angle of incidence to the sine of angle of refraction is a constant for a given pair of media and for light of given color. So you have to end up with the perfect answer. For that color, for that pair of media, this will be a constant. Then what is different? I and R may be any values. You try it for any angle of incidence, you will get this the same. So for that pair, it is a constant. So if it is water, say I have taken water and air, this is constant for air and water. So you go to the lab, calculate it, and you come and say, sir, I got 1.33. Now that constant value has suggested me that this should water, because only for water and air pair I can get this 1.33. I will never get, and of course for a particular color of light I will get it, say yellow color. For other pair of media, say it is plastic and air, or glass and air, I don't get 1.33. So I know this constant value. So if I know this constant value, can I use that constant value for representing the pair of media? For example, person who has scored 596 will get the first rank, say, in the final examination. 594 second rank, 593 third rank, like this. If the marks are like this and the rank is like this, it is an identification for the student. What is your mark? 590. So you are such and such a rank. We can have that communication with them. The rank number and the amount of mark. Similarly, If you have this constant value, will you conclude that this is a such and such a pair of media? Definitely, because for a particular pair of media, this will be a constant value. That is why this constant value is taken as refractive index. This is called refractive index for that pair of media. Remember, index is a number. You have index number in the end of the page. It will help you to identify the page. For example, in a book, if you want to study heat and thermodynamics, you just open the last page of the book and you see, of course, even the content will also tell you. If you go to the index, search that word, they will identify in which page they get that word. If you go to that page, you will get that chapter. Index is a number which points that this is the media. Refractive index, how much velocity of light will change, how much this ray will bend, how much it will undergo refraction. That idea is given by this number. That's why the name refractive index. Okay, we are going to study this in detail. That we will do later. We will come to this now. Sir, what is the problem with Snell's law? Where are the chances of going wrong in Snell's law? We have to study that. 1. You forget to write ratio. Simply write sine of the angle of incidence to the sine of angle of refraction is a constant. No, it is the ratio. Ratio is a very important word. Underline it in your answer book or notes book. When you read it, you will come to know that I will forget ratio. You should write it. The ratio of sine of the angle of incidence. That is one area where you go wrong. Everything will be right. 99% of the words are correct. Only one word is missing. But mark is not 99% given. 100% deducted. So if you want to get 100% mark, ratio of sine of the angle of incidence to the sine of angle of refraction. Some people say, sir, I have written ratio, but I have forgotten sine. I have written ratio of angle of incidence to the angle of refraction is a constant. Wrong. It is the ratio of sine of the angle of incidence to the sine of angle of refraction is a constant. Sin I by sin r is constant, not I by r. So sine, underline it. And at the end, you forget to write for a pair of media it is constant, for that color of light it is a constant. Out of the three, either this medium or this color, if you change any one, you will never get that previous constant. So that has to be mentioned. So in total, Snell's law, which is the second law of refraction, you can't interchange this. First law, incident ray, refracted ray and the normal all lie in the same plane, in the plane of the board. And Snell's law, the ratio of sine of the angle of incidence to the sine of angle of refraction is a constant for a given pair of media and for light of that given color. For that particular given light, for particular pair, whatever be the angles you choose, sin I by sin r is a constant. So this is Snell's law. So that means, coming back here to this, which path will you select to save this person? So if the person is drowning here or sinking here, you select that path so that you want to reach this person and you have to save him very quickly. Select that path such that the angle it makes with the normal, angle it makes with the normal here, refracted ray, sin I by sin r is a constant. So that is the nearest path. And remember, here we can't wait for it and go on calculating, but of course this is the nearest, not the nearest path, is the quickest time at which you can reach the person who is asking help. Okay, now coming back to the refractive index. Suppose you are asked, of course these two laws very important. Here one more. Sir, does Snell's law hold good at every time, at every angle? No, there are certain conditions, certain glitches where Snell's law fails. One is normal incidence. Snell's law fails in normal incidence. Suppose this is a glass slab, this is the normal drawn. Take a laser beam and put the laser beam normally. You know, normal means normal to the surface. Any ray incident normal to the surface passes without bending. It passes straight like this. If it is a reflecting surface, of course, it is reflected normally. But we say it is normally. What do you mean by normally? Normal to the surface. But what about the angle of incidence? Angle of incidence and reflection is refraction is 0. Why? Because angle is not measured with respect to the surface. Angle is measured with respect to the normal. So if the ray is here and normal is also along this direction, I is 0. What about here? R is 0. Because normal is also here. So if a ray of light is incident normally, it doesn't change its path, direction. Not path, it doesn't change its direction. It passes in the same direction vertically below. Angle of incidence and refractions are zeros. So Snell's law fails here. Because if you go on calculating Snell's law now, what you will do? It will be like this: sin I by sin R is equal to sin 0 by sin 0, 0 by 0, not defined. And it has no meaning, because 0 by 0, what is the meaning of 0 by 0? You have to distribute 0 mangoes to 0%. It has no meaning at all. Distribute 6 mangoes to 2 persons has a meaning. Each person will get 3 mangoes, 6 by 2. Distribute 0 mangoes to 0%, no meaning. It is meaningless. It is not defined. So Snell's law fails here. Maybe a question: when does Snell's law fail? Snell's law is a successful law for all the angles of incidence except for normal incidence. When I is equal to 0, R equals 0, ray is along the normal itself. So the angle made by the ray with the normal is 0. Snell's law fails. Here it is not that same constant that you get here. It is the different constant. Of course, it has no number at all. It is an indefinite number. Okay, now coming to the refractive index. What do you mean by refractive index? If you are asked to define refractive index, define refractive index. So, same definition you can take, Snell's law. When a ray of light travels from one medium to another, the ratio of sine of the angle of incidence to the sine of angle of refraction is always a constant. So when a ray of light travels from one medium to another, say rarer to denser medium, it may be any case, I, R. Any I you choose, you will get a particular value of R. Even if you choose a different I, sin I by sin R is a constant. And that constant is called refractive index. Refractive index for which medium? Because there are 3 people who are responsible for refraction. 1, change in media. 2, medias. Suppose there was only air, no refraction. Suppose there was only glass throughout, light would have traveled straight, no refraction. Suppose the light wouldn't have, suppose there is no light, no refraction. Of course, all the 3 are responsible. That should be a light, that should be a pair of media. Light should change its velocity when it moves from one medium to another. All the 3 are important. Now, refractive index of what? To whom this index is referring now? The index is referring to the pair of media. And among the pair of media, here in this situation, suppose this is medium 1 and medium 2. I will make it very clear here. Okay, this much is enough for me now. Right. So when a ray of light travels from medium 1 to medium 2, from where refraction has started? As soon as it enters second medium. From where the velocity has started decreasing? As soon as it enters the second medium. From where the bending has started? Instead of traveling in the original direction, it is in the just when it enters second medium. So second medium is important here. Here the refraction has started. So this constant is called refractive index of second medium. It is the index number which refers to the second medium. Then what about first medium? Sir, whether first medium is neglected here? Not at all. If there is no first medium, definitely we are very sure that there is no refraction at all. First medium is also responsible. So with respect to first medium, right? With respect means it is not with due respect. With respect to means depending on the first medium, how much refraction has occurred. For example, if this first medium was different, then the angle of refraction would have been different. So this ratio is refractive index, but notation you see, it's very important notation. You must be able to follow what is 2-1. Okay? So define refractive index. A question will be only that much. But what refractive index? Refractive index of that medium where refraction occurs, second medium, with respect to the first medium, of course. So refractive index, when a ray of light travels from one medium to another medium, The or we will say the medium 1 and 2. We will represent it as medium 1 and 2. When a ray of light travels from medium 1 to medium 2, the ratio of sine of the angle of incidence to the sine of angle of refraction is called the refractive index of second medium with respect to first medium. And it's a constant we know, that is Snell's law. And that constant itself is called refractive index. So you can use the same sentence here also. So define refractive index. When a ray of light travels from medium 1 to medium 2, the ratio of sine of the angle of incidence to the sine of angle of refraction is called the refractive index of second medium with respect to first medium. So this is the method of writing it here. For example, if you come here, for example, here, if this is the case, sir, here how will you write the refractive index? Whether it is the refractive index of, okay, I will come here first. I will come here. Sir, how do you write the refractive index here? Light starts from air, enters into glass. It decreases its speed and the velocity of light decreases, bends towards the normal. It selects the shorter path. Now, how do you define the refractive index? Sir, here, now, medium 2 is glass. Medium 1 is air. Refractive index of second medium with respect to first. That means refractive index of glass with respect to air, if I want to write. Because refraction has occurred in glass, is defined as the ratio of sine of the angle of incidence to the sine of angle of refraction. This is how do you write. Okay? Because refraction is occurring here. Now, suppose you sit inside glass and put a ray of light into air. It bends away from the normal and moves out. Now glass becomes the first medium, air becomes the second medium. If the ray is put from here, we will go to that case here. Now second medium has become first and first medium has become second. So I'll rub this now. We will come to this case now. So in this case, we have taken the laser beam into water or into glass. Now it is glass. Inside glass, we are putting the ray of light and it's bending away from the normal. Now this is I and this is R. Of course, if I can keep the same I and R, I will keep the same I will reverse the light. If I put the light in the angle of incidence R, it will undergo refraction along I can take the reverse path. Light has a reversible property. If it is made to go back in the reverse direction, it will follow the same path. So I will take a ray of light, put it under the ray of incidence R, let it undergo refraction, bend away from the normal, because this is the original direction, bend away from the normal at an angle of refraction I. So if this is I and this is R, angle of incidence is R, angle of refraction is I. Same diagram reversed. If I take a small mirror and put it here, ray of light returns back and moves like this. Now this becomes I, this becomes R. Now if you take it, now refractive index of the second medium where the refraction is occurring, that is here, with respect to the first, here. I am writing in the reverse way now. The refractive index of the medium where the ray is undergoing refraction, here, with respect to the medium where it is incident, here, is equal to sin I by sin R. Here angle of incidence is sin R by sin I. That is a constant, right? So I can write this as n of air, because refraction is occurring here with respect to glass. So refractive index of air with respect to glass when the light travels from glass to air, because it is n21 always, right? n21, refractive index of the second medium with respect to first medium. So here it was glass refracting, air first one, so NGA. Here it was air refracting and glass first one, NAG. This is sin R by sin I, this one. And you compare this one. Suppose if I want to write this as sin R by sin I, N21 is equal to, I'll bring this 1 by sin R by sin I, right? I'll bring this sin I, 1 by x, that x can go to the numerator, 1 by sin R by sin I can come to the numerator. So that is equal to 1 by, what is sin R by sin I? Sin R by sin I is N12, so like this. So, sorry, 1 by N12, this is N12, yes. So, N21 is equal to 1 by N12, okay. So this is how you have to define it. So always keep it in mind, one aspect clear, that is refractive index of the medium where the ray is undergoing refraction. That comes first. Refractive index of the medium where the ray is undergoing refraction. That comes first. Even if you put a light like this, 1 comes first. If you put a light like this, here undergoes refraction. 2 comes first. So N21 is sin I by sin R. And along with the, sin I by sin R, right. This is how we find out the refractive index of any medium. For example, if I ask you, I'll give a pair of media, not even air. I will give you some oil on the surface of water. Oil can rest on the surface of water. Some amount of oil on the surface of water and then water. So oil and water pair. I will ask you to calculate the refractive index of that pair of media. So there is oil in a beaker on the top of water. What you will do? I will give you a laser beam. I'll give you a compass and protractor and everything, and calculator, everything. You go and calculate what is the refractive index. What you will do? Take a ray of light, you got a laser beam, and make it to fall from oil to water like this. I'll forget about air because my teacher has asked me to calculate the refractive index of water with respect to oil. So let the ray of light undergo refraction in water. Let it be put in oil because water with respect to oil. So let it come like this. Calculate a normal using all the compass, protractor and everything instrument that you have, all your weapons. Use it. Calculate I and R. I, and this is the normal. This is R. Calculate sin I by sin R. What does this indicate? This is the refractive index of water with respect to oil. Am I right? So this is how we can calculate. Now the question is, sir, is it the only way of calculating refractive index? No. Sir, should we calculate every time sin I, sin R and calculate that? Of course, angle, any angle you can choose except the normal angle of incidence where Snell's law fails. Except that you can choose any angle. Okay, sir, is it the only way? No. There are many methods of finding refractive index of any medium. One method is, of course this is very difficult practically it is not so easy. What is the velocity of light in oil? What is the speed of light in water? Divide them. Suppose if I go back to this original diagram, what is the velocity of light in the first medium? What is the velocity of light in the second medium? Speed of light in the second medium. Simply divide it, you will get the refractive index of second medium with respect to first. Right? Even though it is the refractive index of second medium, in the numerator we get the characteristics of the first medium. I, first medium. V1, first medium. And sin R, denominator, R, second medium. V2, second medium. So, refractive index of second medium with respect to first medium is also defined as the ratio of velocity of light in the first medium to the velocity of light in the second medium. Now, by using this, now let me try to confuse you a little bit. Here the ray of light is traveling from 1 to 2. So V1 by V2 is N21. What about here? Velocity should be same, right? In the velocity of light should be same. Velocity of light in glass V2, velocity of light in air V1. Sir, now what is the ratio? You are putting the ray of light from medium 2, that is the first medium now, to medium 1, which is the second medium. You are asked to calculate the velocity of light, refractive index of air with respect to glass. Let the ray of light undergo refraction in air. Then refractive index of air with respect to glass. Refractive index of the medium where refraction has occurred with respect to the medium where it is incident. You know that it is sin R by sin I because angle of incidence is R, light is moving like this. Angle of incidence is R, angle of refraction is I, is equal to velocity of light in the first medium, that is V2, because first medium is this one, V2 by V1, right? So this is N12, am I right? Refractive index of the first medium with respect to second, because refraction is occurring here. So here also you will write the same equation. because n, if I want to write this, n12 is equal to V2 by V1, which can be written as 1 by V1 by V2, that is equal to 1 by, what is V1 by V2? V1 by V2 is n to 1. N to 1. One reciprocal of the other. So, if you know the refractive index of second medium with respect to first, you can calculate what is the refractive index of the first medium with respect to second. Just get the reciprocal. For example, I have given 1.33 in some pair. Suppose this is air, water. Suppose the answer got is 1.33. That is when light travels from air to water. What is the refractive index of water with respect to air? Refractive index of water with respect to air. Then refractive index of water with respect to air is refractive index of first medium with respect to second medium is 1 by n21, because this is n21. This case, suppose you reverse this, then it is 1 by 1.33. That's what you get. So this is how the refractive index is calculated. One major thing that you have to do here, that is, every time when you take any medium, air is a common thing. Take water. Where you will take water? In air. Take glass, in air. Take diamond, in air. Keep it in air. Whenever you want to show anything, you keep it in air. First medium is common. If the first medium is common and if it is air, then we define the refractive index like this. Suppose this is air, and if this is any medium, say glass, kerosene, benzene, water, oil, anything, this should be air. Take a ray of light in air, put it inside water, let it undergo refraction. This is the angle of incidence and this is the angle of refraction. Now, if you want to write what is sin I by sin r, then refractive index of second medium with respect to first medium is defined as the velocity. Okay, velocity I will velocity of light in air is c, velocity of light in the medium is vm, the ratio of velocity of light in the first medium to the velocity of light in the second medium. Of course, v1 by v2, that's what we are writing, v1 by v2. But v1 is a c because it is air. v2 is the velocity of light in the medium. So when you have the pair like this, that is, one is compulsory, air. Second one is arbitrary. It may be glass, it may be plastic, it may be diamond, it may be a liquid, oil, benzene, anything. In such a case, is there any need of writing all these suffixes? No need, because we know that first is air, second one is what is mentioned in the problem or description. So, shall I write this as n only? No suffixes. Sir, you have not written anything here? Not needed, because this is the refractive index of the second medium itself. What about the first one? It is common, air. So shall I write it as c by v only, and deleting all these suffixes? Sir, why did you delete this one? This is the only medium we have here. Other one is air, it is fixed. So the ratio of velocity of light in air to the velocity of light in the medium is the refractive index of the medium, and this refractive index is always referred. For example, if I give you, you will have a confusion. Refractive index of a medium is 2.2. If I say, sir, what pair of medium? Then I will say diamond. Sir, what is the first medium? Need not say, it is air. So if any refractive index is mentioned, then it is for the second medium, a particular medium. But first medium need not be mentioned, it should be air. Otherwise they have to mention. Suppose you have a pair of media like glass and plastic combination, they have to mention first medium is glass, second medium is plastic. Otherwise, if I say refractive index of diamond is 2.22, meaning here you have diamond, here you have air, and if you put a ray of light like this, then sin I by sin r is 2.22. That's all. Or velocity of light in air divided by velocity of light in the diamond, it is 2.22. That is the answer. So, sir, how do you measure refractive index? What is the SI unit? No SI unit, because it is sin I by sin r, and it is ratio of velocity of light v1 by v2. We have the formulas. Okay, I will write it here. I will rub this once. I will finish this. Okay, this concept is very important, because if this is very familiar to you, then the coming things will be very easy. So if I take a medium air, you know that velocity of light in air is c, and draw a normal, put a ray of light and let it undergo refraction, bend towards the normal. This is the angle of refraction, like this. Then okay, like this, this is say some medium, right? I need not write any suffix because I know what medium I have given. Refractive index of any medium with respect to air, everything is understood, is the ratio of velocity of light in air to the velocity of light in the medium. And if I take it as 1 and 2, you know how to write it. Refractive index of second medium with respect to first, because I don't know what media they are, then the velocity of light in the first medium, I don't know whether it is air or something else, second medium, which is also is equal to sine, ratio of the sine of the incidence to the sine of angle of refraction, that ratio, and that can also be written by one more formula, that is lambda 1 by lambda 2. What is lambda 1 by lambda 2? So you have plenty of ways of finding the refractive index. What is lambda 1 by lambda 2, sir? It's very simple. You know that a white light, any ray of light, when it travels from one medium to another, its wavelength changes. Red light will not be the same red when it travels into glass. Blue light will not be the same blue. It will not have the same wavelength when it enters the glass or water. Wavelength of light changes when it travels from one medium to another medium. So, what is the wavelength of light in the first medium? What is the wavelength of the same light in the second medium? Get their ratios. That gives the refractive index. So, you have plenty of ways. Of course, this is not for the time being. This is very important. The ratio of velocity of light in the first medium to the second medium, sine of the angle of incidence to the sine of angle of refraction, I is in first medium, R is in the second medium, the ratio of wavelength of light in the first medium to the second medium. Now see this formula. Can you assign any value or any unit for refractive index? No unit. I did simply wrote 2.22, 1.33, I didn't give any unit. Reason is meter per second, cancel. Of course these two don't have any unit. Meter, wavelength, nanometer, micrometer, meter got cancelled, so no unit. So that is how we study refraction. So when a ray of light travels from one medium to another, how much its velocity has decreased and how much its velocity has increased, all these criteria will be given by only one word, that is refractive index. Just after coming to know the refractive index is this much, you will clearly understand what type of medium it is. Sir, how come, sir? For example, one more. This is the last point that I will discuss in this, then we will finish it. Okay. Refractive index of glass is 1.5. Say it is one type of glass. Refractive index of diamond is 2.22. No unit? What does it mean? Sir, how this value has come out? Very simple. Take glass, you have outside air, take a ray of light, say yellow color, let it enter into glass, measure the sin I by sin R, then this answer you have got. So refractive index of glass is 1.5, means it is the ratio of velocity of light in air, because you have to take glass and air first medium, glass second medium. Ray of light should pass like this. So you have to take velocity of light in air to the velocity of light in glass. This is one answer. What about refractive index of diamond is 2.22. Then refractive index of diamond is 2.22. The meaning is you have to take diamond here, air here. It is the ratio of velocity of light in air to the velocity of light in diamond. See this? What you can conclude? In both the equations, this is a constant. Then will this value, what you call refractive index, tell you what is the speed of light in that medium? Definitely. Since refractive index of glass is less, this answer should be more, because denominator should be more if you want to get lesser answer. If refractive index of diamond is more, if this answer is obtained, of course C is the same C that we have used here, this answer should be less. So here velocity of light in diamond should be less, and that's why we landed with more answer. Velocity of light in glass should have been more, that's why we landed with the less answer, because both the cases, the velocity of light to which we divide the velocity of light in the medium, that velocity of light is common in air. So velocity of light, refractive index of diamond is more, refractive index of glass is less. What does it mean? Speed of light in glass is more, speed of light in diamond is less. So you can conclude it like this: if velocity of light in glass is if refractive index of glass with respect to air, that I don't write, is lesser than the refractive index of diamond, the meaning is velocity of light in glass should be more than velocity of light in diamond. Simply speaking, refractive index is inversely proportional to speed of light in the medium. So final conclusion is, more the refractive index for a medium, that constant value, it does mean that lesser is the speed of light in that medium compared to the other medium. So more the refractive index of a medium, lesser will be the speed of light in that medium. So the medias where light travels with more and more speed, their refractive indices will be lesser and lesser. Media which has a refractive index lesser and lesser, the meaning is in that media light can travel more and more faster. That is the beauty of refractive index. So that is why, suppose you are going to a doctor for spectacles, if the doctor prefers you a spectacle, if you go to the lens maker, lens shop, immediately they will ask which material you want for the spectacles, whether it is plastic, whether it is fiber, whether it is glass, whether it is diamond, you will choose it, but they will choose the refractive index of that material. According to that, they will apply some formula and prepare the spectacle. So for any type of motion of ray from one medium to another, this value is very important, refractive index, that will tell you how fast the light travels in that medium. So you have a medium of very high refractive index, meaning is light travels with least speed in that medium. You have a medium of less refractive index, light travels with most speed in that medium. Now last point, come to air. Okay, if you want to find out the refractive index of glass, what you will do? Take glass in air, from air to glass put a ray of light. Velocity of light in air divided by velocity of light in glass, that will give you the refractive index. Sir, I want to find out the refractive index of diamond. Take diamond, from air put a ray of light to the diamond. Velocity of light in diamond will be less. So ratio of velocity of light in air to the velocity of light in diamond, that gives the refractive index of diamond. Sir, now who will find out the refractive index of air? For every medium, air has given company. Now who will take care of air? Okay, you want to try to find out the refractive index of air, right? Take air, keep it in air. Take a ray of light from air to air, because air is a medium which gives company to everybody. Air to glass, air to diamond, air to water. So take air, keep it in air, take a ray of light, velocity of light in air is c, let it enter into air itself. There is no media separating, it's just an acting here, there is nothing media separating, both are air. Velocity of light in air is here also. So what is the angle of incidence, what is the angle of refraction? No meaning this one here, simply playing here. I and R are same, because light is traveling in the same media, no refraction at all. So what is the refractive index of air with respect to air? It is the velocity of light in air to the velocity of light in air, that is 1. This is the least value of refractive index possible, because you know, refractive index, lesser the refractive index, more will be the speed of light in that medium. Lesser the refractive index, more will be the speed. You know that light travels with the maximum speed, tremendous speed in air. There is no other media or vacuum, there is no other media through which light can travel faster. So if light is fastest in air, then the refractive index of air should be least. There shouldn't be any media other than air which will have refractive index lesser than 1. Of course, there is a meaning for refractive index less than 1. You will study that later. For the time being, Air has the least refractive index, its value is 1, because velocity of light in air to the velocity of light in air ratio is 1. That is the medium where light can travel with the highest speed, and no medium we will have where light travel with more speed than that of air. So every medium will have refractive index greater than 1 other than air. So this is the beauty of refractive index. You should have a clear idea of this. If you just rewind this video back and try to see what are all these things, I don't know whether you have followed this or not. You might have got confused when you change the media from one to other. In the next class I will try to recap it again. Of course, video can be recapped again, but still you will get the same explanation. Let me try to put in different way so that you will understand it. But this is a very basic thing, and if this base is very strong, we can move forward. Thank you, and keep learning this, studying this. Thank you.